So in this second video, I'm going to continue with my work on lesson 11-3, and I showed you yesterday how to describe the shapes of data, and we did an example A, which we described the shape using a histogram. So I want to go back up here, and we've already described the shapes. Now we're going to use the shape of data to choose appropriate measures. That's what we're going to do in example B today. So what I'd like you to do, just in order to reinforce your learning from example A, is I'd like you to go in and do the monitoring progress, which is at the bottom of page 20. And what you're going to do is create a frequency. You're going to use this frequency table. You're going to describe the shape of distribution based on the histogram that you do right there. Okay, so that's what you're going to do, and then I will post this answer on Canvas so you could double check your work. So moving on, what we are now going to do is I'm going to look at page number 21. And in page 21 of the same lesson, we are going to be choosing appropriate measures. Well, what I'd like you to do is, we already talked about this with regards to using a box and whisker plot, and the same information holds true. So when I have things that are skewed, I have to use certain measures of center to be able to describe the data. So let's take a look at when something is symmetric. So this is symmetrical data. And when I have symmetrical data, what I'm going to do is I'm going to use the mean to describe the center, which kind of makes sense. We've already talked about that with regards to if I just have mean, median, and mode, that the mean is good if I don't have an outlier. Same thing with box and whisker. The mean is great when I have a symmetric box and whisker plot. Same holds true when I'm looking at histograms. So it means that the mean and median are about the same when I've got symmetric data. So then when I have data that's skewed, notice what happens. We're going to use the median to describe the center. And we do that because that outlier, that number, those numbers that skew, or that information that skews our average, it's better just to use the median. So notice here, notice where the mean is when my data is skewed. So the mean, if this is most of the data here, right, the mean is in the direction in which the distribution is skewed. The median is going to be less affected. So this is my tail. Remember, this is my tail. And most of the data is on the right. Therefore, my distribution is skewed left. Same thing here. Most of my data is in this area right here. Notice where the mean is located. The median is right here. This is the tail. And if most of my data is on the left, then this is skewed right. All right, so now we're going to be looking, we're going to be creating a histogram, and we are also going to be looking at the shape of distribution. So let's go ahead and get started. Here's my problem. It says I've got a police officer that's measuring the speed in miles per hour of, of 30 motorists, and the results are shown in the table at the left. Nope, that's another typo. Oh my goodness. It's on the right-hand side. So what are we supposed to do? We're supposed to display the data in a histogram. Oh, so wait a minute. And I'm supposed to use 6 intervals. Oh, so I don't have a frequency table. So they want me to create a frequency table right here using this data. So I've got some work to do. So I'm going to go ahead and follow along with what I do first. So the first thing I do is, I know I've got some data right here, and they're all the different speeds, and it's asking me to display this data in a histogram. So this is where I'm going to make my histogram. But I need to make a frequency table first. So what I'm going to do is I'm going to go ahead and use, here's my first interval, 31 to 35. I'm glad they gave that to me. And I'm going to notice some things about this interval. Notice there are 4 numbers between 31 and 35. So I'm going to go ahead and I'm going to create my frequency table based on the intervals of 4. So my next number is 36, and I'm going to go to 40 because I've added 4 onto 36. Now where do I start my next interval? At 41. So I'm counting up by 1. So 40 goes to 41, and now I'm going to add 4 to that, which means I've got 45, and I'm going to continue that same pattern. I've got 46 to 50, 51 to 55, and 56 to 60, and 61 to 65. Okay, so I've got all my intervals. So now what that means I have to do is go into my data right here and count off how many times do I see those numbers using these intervals. So 31 to 35, I'm going to look at my data, and I'm going to notice I've got a 32 right there. That's 1. I'm going to go through, do I see any other numbers between 31 and 35? No, I do not. Therefore, I put 1. So now I'm going to keep going, and I'm going to just count up. 36 to 40, I've got 3 numbers. 41 to 45, I've got 5. 46 to 50, I've got 6. 51 to 55, I've got 11. 56 to 60, I have 4. And 61 to 65, I have 0. So you can see on my work, I had already done the work right here. I just went in and I counted how many times I saw these various numbers. So I've already done the work, so I didn't want to bore you with having you watch me count. So now that I've got my intervals and I've got the frequency of how many times I see those speeds in those intervals, I'm going to go over here and I'm going to now start to create my histogram. What does that look like? Well, that means I have to put a title on this. So I'm going to write my title being the speeds of motorists. What else do I have to do? I have to label my axes. So I'm going to write frequency on the left. And what do I write on the bottom? I'm going to write speed, because that comes right out of my table. And how did I measure speed? I measured it in miles per hour. Okay, so now I've got to write my frequency numbers right here, and I'm going to look at my data. And I've got from 0 to 11. So I'm going to start here at 0, and I'm going to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I don't have enough, so I'm going to actually mark an 11 right there. So now I need to write my intervals down here at the bottom. So I'm going to take them right off of my table. And so my first interval is 31 to 35, 36 to 40, 41 to 45, 46 to 50, 51 to 55, 56 to 60, and 61 to 65. And I go in and I just put little tick marks. I darken them up so it makes it easy for me to see. Alright, so now I'm going to take this data, these frequencies, and I'm going to place it right here on my histogram. So how many times did I have 31 to 35 miles per hour? I only had it once. So I'm going to draw my box. How many times did I have 36 to 43? So I'm going to go ahead and do that. And I'm just going to continue putting in all of my data based on my table. That's 6. 51 to 55 is all the way up to 11. 56 to 60 is 4. And 61 to 65 is 0. Notice I have 0 right there. I'm not going to put any on this histogram. So now I need to look and see what's going on. I'm going to go ahead and draw a line a dotted line. Remember I said I'd draw a dotted line. And I'm going to actually include the 0. So take a look at that data. I've got a tail right here. What else do I notice? I've got this really tall bar. This means that all of my data, I've got 11 of these, most of my data is over here. How do I know that most of my data, because I've got 11 of these speeds that are showing that they are between 51 and 55. So this is a skewed distribution. I know that it is. So now, skewed what? Well, if I have a tail over here, most of my data is on the right-hand side, then it is skewed left. All right, so these are just observations that I made based on this histogram. I haven't even answered questions yet. So let's go ahead and answer the questions. What measure of center and variation best represents the data? Well, what are the measures of center? They're my mean, my median or mean, and mode. And what's the variation? Well, the variation could be standard deviation. It could be the range. It could be my 5-number summary. Remember we talked about that in this box up here and right here. Tells us that when I have a mean, when I have a symmetrical shape of data, I'm going to use the standard deviation to describe the variation and the mean to describe the center. When everything is skewed, I'm going to use different measurements. I'm going to use the median to describe the center, and this time I'm going to use the 5-number summary, which is part of the box and whisker plot. So let's go ahead and answer this question. What measures of center and variation? So I'm going to notice that most of the data is on the right. Right? Thus, distribution is skewed left. Because it is skewed, you are to use the median as a measure of center. And the 5-number summary to describe variation. So now I got to answer the second question. It says the speed limit is 45 miles per hour. How would you interpret these results? Well, I had 11 motorists that were going 51 to 55. So basically, everyone else is speeding. Most of the data shows that the motorists are speeding. That's what it means. So now what I'd like you to do is flip it over, and I would like you to do number 2 on your own. And then I'd like you to draw the 3 histograms and showing skewed, something that's symmetric, something that's skewed left, and something that's skewed right. And go ahead and do those, and then double check on Canvas to see if you've got them right.